So once again, good morning. So this is the video lecture on third sem subject data structures and its applications. So in today's class, now we are going with module 4. So what is module 4? So till now we have seen data structures. So which are the different types of data structures we have? Primitive data structure and non-primitive data structure. So under primitive we have linear and non-linear. So linear data structures we have gone with a stack, queue, linked list. So these are the three data structures what we have linear. So come for the non-linear data structure. So non-linear data structure we have two types. So one is the trees, the other one is the graph. So first we shall see the what is the definition of what is a tree and what type it contains. Okay, so in today's class, so first we will go with a trees introduction. So first this is the tree concept. Under that you are going with the terminologies. Next we go with a binary tree. Next types and properties of binary tree, and finally array representation of binary tree. So there are four concepts we will be discussing in detail. So start with a tree terminologies, binary tree, properties and its array representation, how we represent binary tree. Okay, so next you come with a definition of the tree. So what you all mean? So tree means, so you take a basic example what the tree will contain. Tree will consist of branches and leaves. Okay, so whatever you consider, it is a it will consist of branches. So branches with leaves and all. Okay, so each tree what we contain here we consider it as node. Okay, so here you can see the definition. What is tree? It is a finite set of elements. So it is a finite set of elements that is either empty or it is partitioned into subset. So keep this one in your mind. It is a finite set of elements. So that is either empty. Empty means here what you are seeing here A. So here it is not containing any branches, nothing is there. So it doesn't contain any branches or leaves. So this one we call it as, it is a empty tree because it is consisting of how many node. So here each one we call it as node. So this one is not containing any branches or there is no any leaf nodes. So that is why we call it this one as empty node. Okay, or so that is either empty. So that is either empty means this one. Okay, so next it is partitioned into different disjoint subset. So it is partitioned. So take this example now. So A, here it was empty set. Now this one it is been partitioned into two sides. So on left as well as on right. So on left, this one is called left subset and this one is called as a right subset. So keep this one in your mind. Any tree is divided into two sets. So on first set, what you are going to divide, we call it as left set, left subset, and what you have on right is called as a right subset. So that's why we give it as, it is partitioned into different disjoint. So disjoint means not same. Okay, so what's the meaning of disjoint? So here you can see disjoint means not same. That is the meaning. So that means how you tell disjoint. Here in left subset you see how many elements are there. 1 2 3. On right subset how many elements you are having. 1. So here it is 3 and here it is 1. That's why we consider it as different disjoint subset. So because here we contain 3 elements and here we contain 1 element. Okay, so now this is the another example. So here you see how it is going to be. So go for the third diagram here. This is the node. Okay, so this node is connected to node B and this is right. So which is the left? Left is B right is D, middle one is C. So if you are having only two, that you call it as left and right. If you have three, then we consider it as left, middle and right. And middle is again having two. So here you see it is disjoint because on left subset we have one, on right subset we have one, on middle subset you are having three. Understanding? So that's why we call it as different disjoint subset. Different disjoint subset. Okay. So now what is the tree? It is a finite set of elements that is either empty or partitioned into different disjoint subset. Okay, so now it is a non-linear data structure. As I have already told you, linear data structures are stacks, queues, linked list. So non-linear data structure are trees and graphs. Okay, so in that we are discussing with tree. Okay, so tree is a non-linear data structure which represents the nodes connected by edges. So it represents nodes connected by edges. Okay, so how many nodes we have here? One node. How many nodes we have here? 1, 2, 3, 4, 5. 5 nodes with how many edges? So as edges means this one represent the nodes. So A and B node are connected by one edge. A and C node are connected by another edge. So how many nodes are there? 5 nodes are there. How many edges you have? 1, 2, 3, 4 edges we have. So similarly come for here. How many nodes you have? 1, 2, 3, 4, 5, 6 nodes are there. How many edges you have? 1, 2, 3, 4, 5 edges you have. So that is up to the definition part. Okay, so under trees now we have seen. Next you come for the very important part, terminologies. So answer the question. Is tree a linear data structure? Answer to my question. Is tree a linear data structure? No. Okay. Then what it is? Yeah, tree is a non-linear data structure. Okay, so can you tell which are the linear data structure example? Linear data structures. Example. Array. Then stack, queues, arrays. Good. Okay. So now we are discussing about non-linear data structure. Okay. So under this, now you come the terminologies. So terminologies are very, very important from exam point of view. So I will give you so many stars. So it is important for exam. Okay, so what are the terminologies of trees? Then you have to write all these things. Okay, so first you start with a parent. Okay, so parent is also called as, so parent, ancestor or parent. So any node except the root node that has one edge upward, we call it as parent. So come for this tree. So any node except the root node, which is the root node for all the trees, it is A. Okay, so root node is the first node what you have. So first node is called as a root node, and middle one we call it as a internal node. Okay, and below, last below, we call it as a leaf node. So first we start with a root node. So middle what we have, that we call it as a internal node, and then what you get below, that we call it as a leaf node. Okay, so now you come for the parent. Any node except the root node that has one edge upward to the node. So that is any node. So D can be E also the node. So D and E, the parent is B. So for B and C, parent is A. So that is the ancestor or parent that has any node that has one edge upward to the node. So who is the upward of D? Upward of D is B. Upward of C is A. Okay. So now you come for the second one, child. The node below the given node connected by its edges downward. So any node connected by an edges downward. So upward means you have to go up. So from D to A is called as a upward. So similarly for the child, a node below a given node connected by its edges downward is called child node. So for node A, which are the child nodes? It is B and C. So for node B, which are the child nodes? D and E. So that is called as a descendant or child node. Okay. Now you come for the siblings. The children of the same parent is called as siblings. The children of same parent. Okay. So now you can see which are the siblings of A. B and C are the siblings of A. Similarly, D and E are siblings of B. So, siblings of A is B and C. Siblings of D and E are B. So can now you answer. So now you answer, what are the siblings of A? Go for the third diagram. So under third diagram, what are the siblings of A? Siblings of A is B, C, D. Okay. Siblings of C, siblings of C is E and F. Okay. Come for the second diagram. So in second diagram, siblings of A, in second diagram, siblings of A, B, C. Okay. So now you come for the depth. Next concept, that is depth. So depth of a tree is a maximum level of any leaf in the tree. Okay. It is a maximum level of any leaf in the tree. So for example, here you see this is only, so example one, first tree, second tree, third tree. Okay. So here there is no depth because it is the only node you are having. So come for here. What is the depth? It is the maximum level of leaf in the tree. So what is the maximum? Which are the leaf nodes here? So in second diagram, leaf nodes, root node is A, internal nodes are B and C, leaf node are D and E. So what is the depth of the second tree? Can anybody can answer? What is the depth of the second tree? What is the depth? 2. So how you tell it is, how you tell it as 2? So depth is a number. So it is a maximum level of any leaf in the tree. Okay. So it comes under what is the number you have. Okay, so depth of a tree that we take it as 2. So because root node is at 0, so B depth is at 1 because it is at location 1. Okay, so D and E, the depth is D and E is at location 2. So root node A at location 1, B and C are at level 1, level 0, level 1, this one is at level 2. So that's why we call it as depth. Depth is a maximum level of any leaf in the tree. Okay, so come for this one. So come for the third diagram. What is the depth? So what is the depth for third one? Okay, it is also 2. Is at level 0? Level 0 we have A. So B, C, D we have level 1. E, F we have level 2. So that's why we call it as it is at level 2. Okay, now you come for the next one, height. So distance of a node from root node. So you have to start from root node. In number of levels is the height of that node. Okay. So height of a node. So depth of a tree. So keep this one in your mind while going for depth of a tree. Okay. So now you have to go with the height of a node. So height of the node, how you take? The distance of the node from root node. Distance of the node from root node in number of levels is the height of that node. So number of nodes which must be traversed from root to reach the leaf of a tree is called a height. So what is the height of the node A? So anybody can answer. What is the height of the node A in second diagram? Height. Sorry, height of a node. Okay, it is 0. So as I have already told, height of a node means distance of the node from root node in number of levels. So I have already told A is at level 0, B and C are at level 1, D and E are at level 2. There is no means of 3. 3 is wrong. So you will get only the 3 numbers. 0, the B and C are at location 1, D and D are at location 2. So what is the height of a node? So height of the node A is 0, height of the node B and C is 1, height of the node D and D is at 2. Okay, that is called as a height. So now you come for the next one, forest. So set of trees is called a forest. So if you place all these trees in one particular parameter, so this one, all 3 trees, we call it as forest. Because what will be there inside the forest? General meaning. So many trees with plants will be there. So that's why we call all the set of trees, we call it as forest. Now you come for the next one, path. So path refers to sequence of nodes along edges of the tree. So sequence of nodes along edges of the tree. That means path means you show the directions. So can you tell, now you consider the example A to D. What is the path from A to D? It is A to B and B to D. So what is the path from A to E? It is A to B and B to E. So similarly, in third diagram, can you tell what is the path from A to F? So can you tell what is the path from A to F in third diagram? Good. It is A to C and C to F. So what is the path from A to E? A to E. So it is A to C and C to E. Okay, that is the path. Now you come for the next one, root. The node at top of the tree is called root. So which are the node at top of the tree? So which are the root node here? It is A. Okay. So there is only one root per tree and one path from root node to any node. So keep this one in your mind. There will be only one root per tree. So it is only one root per tree and one path from root node to any node. Now you come for the external node. External means which are outside. So external nodes means which are outside. So node which does not have a child node. So A is having childs B and C. So C there is no node. So node which doesn't have child node is called leaf node. And so here D and E doesn't have the child. So that's why we call it as D and E are the leaf node. So in third diagram, which are the leaf nodes? So answer to my question, so which are the leaf nodes in this particular third diagram? So keep in your mind which doesn't have the child. So B is not having child. B, E, F, D. So these are the child nodes. Okay. So now you come for the next one, non-leaf or internal node. So internal means node which has at least one child is called internal or non-leaf node. So come for the second diagram, which are the internal nodes. Second diagram, internal nodes. So internal nodes, sorry, it can't be A. A we consider it as root. Okay. A is considered as root. We can't consider it as internal node. Node which has at least one child. So which has at least one child. So that is we consider B. So come for third diagram. So third diagram, which is the internal node? Internal node is C. Okay. So now you come for the next one, subtree. So subtree represent descendants of the node. So I was already told you tree will consist of left and right. So left part we call it as a left subtree. Subset is called as a subtree. So that we call it as left part. What is the left part here? So left part is B, D, E. It is a left subtree. And A then C, we call it as a right subtree. So here also you can see. So here B is considered left. This one is considered as middle. This one is considered as right. So this one, that's why we call it as subtree. Next, visiting. Visiting refers to checking the value when control is on node. So now you come for the visiting means. So checking the value of the node when control is on the node. So next you come for the traversing. Traversing means passing through nodes in specific order. So that means, so you, So traversing means passing through nodes in an order. So if you are moving from left, so there are three traversal techniques that we will see, but you go with a definition here. So definition means passing through nodes in an order. So there are three types of traversing. So pre-order traversal, in-order traversal, post-order traversal, that we will see in the next coming classes. Okay. So now you come for the last level. So level of a node represents the generation. If, as I've already told you, root node is at level 0, then its child node are at level 1 and its grandchild are at level 2, so on. Okay. So next you come with a keys. So keys represent value of a node based on which, why you use the key? Key is used for search operation. So keep in your mind, keys are used for search operation. Search for a node in a tree. Understood? So if you are searching for a node in a tree, then you use the concept keys. So have you understood all these terminologies? Have you understood all these terminologies? So it's very important from exam point of view. Example for visiting. Okay. So you want an example. Now you see if there is a path from A to D. So which are the nodes you are going to visit? That will be the visiting nodes. Checking the if I want the path from A to D. So what is the path from A to D? In second example, what is the path from A to D? AB and BD. So which are the nodes you are going to visit apart from source and destination? So I want the path from A to D. So source is A, D is the destination. So which are the visiting nodes? Apart from A to D, visiting node is B. So that will be the value. Okay. So come for the third example. Suppose I want a path from A to E. Which are the nodes visited? There is a path from A to E. Which are the nodes visited? Nodes visited, you have to, apart from source and destination, you have to take the remaining one. So that will be the visiting nodes. So leave this source. Leave the A, leave the E. Apart from A and E, which are the nodes visited? It is C. So C is the visited node. So use this link to answer your attendance. Have you understood up to here? So this will be up to the first topic, that is tree definition and terminologies of trees. So in tomorrow's class, now we shall see binary tree types and array representation. So in next class we will discuss with binary tree and its type and array representation. Understood? So I wind up the class for here. So thank you one and all.